Okay, so today we are going to be covering batteries, and when you're doing batteries, of course you want to make sure that you are always very safe in what you do, and you always want to make sure that your car has the preferred battery. Now, in order to find, when you're looking for the preferred battery, you want to look at the cold cranking amps and the BCI group. Those basically talk about what the recommended battery for your car is. Now, we use Napa ProLink, but if you don't have access to this, you can go look probably by your vehicle manufacturer, or somebody else online has probably posted it. And being that, we can see that the cold cranking amps for this battery should be 550 and the BCI group is a 35. So that would mean that we have the correct battery. Okay, so the next thing we're going to do is we're going to talk about how to test the battery and test maybe if you're only getting 10 volts out of your battery or so, and you continue to put it on a charge and it won't get more than that 10 volts or so. What you can do is, if you have a maintenance style battery like this with these covers, you can pop the covers off, and if you have this is called a hydrometer. You can use it to test the battery, test each cell individually. You just take it, you let it fill full of water, and as we can see, it's way up above 1300, and we can see that this cell is good. And then you just go along and do this with all 6 and find your dead cell. Okay, so in order to determine what is considered a fully charged battery, the specific gravity of the battery and all the cells combined should equal up to 1265. And as you can see, our meter goes a little bit past that, but at least we know that our measurements will be good. If you have a maintenance battery like this where you can pull the covers off and look at the cells, and you want to determine if your battery can be serviced or not, the thing you want to do is, when you're doing the hydrometers, each one of your cells, if there are any 2 cells that the maximum difference is more than 0.025, then you know that your battery is unserviceable and you need to go ahead and get a new battery. If you have a battery and you determine that it has a dead cell, the dead cell is most likely caused by a loss of water in the battery due to high evaporation under the hood. With all the heat that's going on, it's common in most older batteries, so it's probably just time for a new battery. Okay, so as we've determined, the hydrometer tells us that this battery is dead, and we've pulled it from the vehicle. But when you're working with the battery, you want to make sure that you have safety glasses and anything else you think you might need in order to safely work on the battery. And now we're going to go ahead and do a open voltage test on the battery. And in order to do this, you want to take the voltmeter, make sure you get it in the correct range, and then you just want to test the battery just like you would inside the vehicle. And as we can see, we have about 12.3 volts of electricity. Okay, so the next test that we're going to do is going to be called a conductance test. And what this will show us is how many cold cranking amps the battery has versus what it's rated at. So let's go ahead and hook our connections up. And you've done it right when the meter comes on. And we'll go ahead and show them that our battery's got 12.2 volts. We'll go ahead and it's out of vehicle, so you click out of vehicle. It's an automotive. It's a regular flooded battery. We want to check the cold cranking amps. It should be at 650, so click that. And as you can see, it's performing the test. As you can see, it shows we have only 48 cold cranking amps when we should have 650. With it being that low, you should know that we automatically need to go ahead and replace the battery because it's no longer good. Okay, so the next thing we're going to do is we're going to go ahead and do a battery load test. And when you check this, you want to make sure that your connections are all hooked up, and you want to check and see that the battery says 575 cold cranking amps, so when we load test, we need to have around 278. So we're going to go ahead and make sure this is right. You want to start to turn this, the light comes on, you want to zero this out, and as you can see, our battery is good. Okay, next we're going to be going over the difference between a fast charger and a trickle charger. Here we have a fast charger. The difference is that with a trickle charger, it is designed to use a low amount of amperage over a longer period of time in order to get the battery deeper charged and to allow it not to lose the normal charging that you lose. And today we're going to cover as well how to operate a fast charger. And when you do this, you want to make sure that you first have all your safety protection before you do this, and you want to make sure you come over and you want to hook the positive up to the positive terminal. Then you want to take the negative and find a good ground and make sure that your negative terminal is connected. And then you want to plug the fast charger in, which we have already done. And then you want to come over and turn it on, and then you are all set.